Hello, friends. Welcome to Akulmach Live. And you know that there are supermassive black holes in the core, in the center of every large galaxy. In fact, every galaxy. But our universe is only 14 billion years old, roughly about 3.8 billion years. And this is not the time which, a black hole will require to become so large. There are black holes which are million times the mass of our sun, and then there are black holes which are multi-billion times the mass of our sun. So it's a mystery, how the black hole actually became so large in a very short period of time. But let's move on. One of the methods that the scientists propose that by merging, by colliding with each other, large black holes can actually double their size, or many times the original size, by just merging with each other. So that is one hypothesis, that if there were many black holes, they merged together, they could have become supermassive black holes in a very short period of time. However, today we are discussing about whether this merger is going to happen successfully or not. What are the bottlenecks? One of the bottlenecks is that when these black holes are coming close to each other, and they need to basically reduce their energy, because there is a law where the circular momentum or the orbital velocity requires reduction in the energy, and every black hole has an accretion disk around it. So what happens is, when these two black holes are approaching each other, the accretion disk basically absorbs the energy from the black hole, and it becomes heated up. So that is a telltale sign that these black holes are going to merge. Until then, they are very close, and it is 1 parsec. 1 parsec is equal to 3 light years. When these black holes are coming to close to each other, the energy in the accretion disk is not sufficient for black holes to provide any energy transfer when they are just 3 light years away. You need much bigger energy transfer mechanism so that these two black holes can merge. Yet, scientifically we cannot prove, mathematically we cannot prove, but they actually merge. We know that. So this is the discussion that we are going to do today. And before we begin, a word on our sponsor. Sponsor of this live stream is Boat. Boat is the manufacturer of audio devices, which like headphone and your earbuds. Very good quality from India. So if you're looking for changing your current devices to something elegant, something more interesting, and also at low cost, the link is in the description. Specially curated devices are listed on that link. So do check them out. All right, let's begin. And the first issue that we find is how these supermassive black holes basically formed in the first place. And the final parsec problem is, I've already told you that final parsec is equal to 3 light years, because that's a measure of how quickly things move. So parsec is a measure of that, and each second, which is parsec, each second is equal to 3 light years. So when these black holes are coming towards each other, in order to become larger, the energy dissipation that these black holes will have to undergo, there is not enough material in the accretion disk of these individual black holes to absorb this energy and become heated up again. So that is a big trouble. At the same time, the black holes are something which are very, very large. And there is another mystery that we find today, that the difference between the stellar black holes and the supermassive black hole, there is nothing in the intermediate range. Typically, it should be in all kinds of ranges. If you have a stellar mass converted to a black hole, and then we should also have multiple times the stellar mass of the black hole, we should see them, but we do not see them. We see stellar black holes, and then next stage we see the multiple times, billions of times the mass of the stars black holes. There is nothing called intermediate. So that's the big mystery that we are not able to solve. Where are those intermediate black holes today? We know that the gravitational waves are telling us that the merger of the black holes are happening everywhere. There are small black holes merging together, there are large black holes merging together. Whenever the galaxy collide with each other, the central black holes actually merge and become larger. We know that that is happening, but we are not able to prove that mathematically because the energy required to dissipate, basically these two black holes which are about to merge will need to reduce their energy so that they can come close and then eventually merge. So we are not able to get the mathematical formula simply because there is not enough mass around the singularity, which is the black hole itself. You know that black hole is a very strong object, very strong gravitationally active object, which even attract light. So when something goes very close to the black hole, it will absorb and then it will be lost forever. So something has to be there around black hole which is not so close that it falls into the black hole. At the same time, it is able to absorb the energy, and that is the accretion disk around it. The swirling mass of gas, very superheated gas, moving almost 30 to 40% of the speed of light. So that accretion disk absorbs the black hole energy so that they can come close. But when when they start coming closer to each other, the energy dissipation is required of multiple magnitude. That means if they are coming close, more and more energy needs to be dissipated. Otherwise, they will go away or they will remain in a stable orbit. So we don't want that to happen. Especially when we started off our discussion that the universe is only 13.8 billion years old, and the mystery is how these black holes merge together to become these humongous sized black holes. We know that practically when we observe the gravitational waves, the mergers are happening. We get the black hole merger gravitational waves every day, but we are not able to prove that mathematically, simply because once they are coming closer, the accretion disk is not enough mass to absorb more energy, because accretion disk by this time has already absorbed a lot of energy. So that is a mystery that some scientists have been able to provide a hypothesis, although there is no proof. Now the scientists are saying that we know that the mergers are happening. We know that the black holes are merging together to become larger, and once the black hole becomes larger, and they are able to actually control a lot of stars around them, and eventually they will become super massive black holes or ultra massive black holes, and the size of the black hole determines the size of the galaxy. We know that there are trillions of galaxies all around us, and with the supermassive or ultramassive black holes in the center of each galaxy. So we know that this is happening. So scientists are saying that we are not considering the dark matter. So we are only considering the accretion disk, which is a visible matter. We know that the dark matter is something which is, we have not got any clues where the dark matter is, but we know that the dark matter is something which is real. We know that the dark matter is the material responsible for creation of the universe, visible universe, which is stars, galaxies, and even black holes. Dark matter provides extra gravity for everything to come together. All of these things that we see is because of the dark matter. So we know that dark matter exists around black hole, and we are not considering that so far. So I think that is one thing which scientists are saying, that we must use dark matter as one of the clues which will enable collisions and mergers, and thus the black holes will become larger. So how does this dark matter work? The dark matter is a matter which is a very classical matter. Dark matter is the matter which does not react with any of the visible matter or itself. It is a very classical matter which we cannot see. Since it does not react with anything in the universe, we do not get to observe dark matter, because our observation abilities are limited to what we see. If the light or some sort of input doesn't come, we will not be able to measure this accurately using an instrument. Something has to come in. So therefore, this is something which is a mystery. Even dark matter is a mystery. We haven't been able to isolate dark matter from the real matter because we do not see any observation clues in the universe. Now, if there is dark matter around the black hole, then the dark matter will provide extra gravity. Well, this is fine. Dark matter is there. It will provide extra gravity. However, how dark matter will dissipate the excess energy which the black holes are having, so that when once they lose energy, they will actually get into a tighter and tighter orbit as we proceed in future, so that eventually they will merge. That means the dark matter is there in and around the accretion disk or within the black hole itself, we do not know. But if the dark matter is able to take that excess energy, then the black holes will be falling towards each other. And I think that is one thing which the scientists are now debating. One of the methods the dark matter will be able to absorb the energy of the black hole is based on the interaction with each other. Because if the energy has been taken, the dark matter will actually get heated up. But we do not see that. That is why the observation says that the dark matter is not there. We only look at the accretion disk getting heated up, superheated, moving at very high speed, almost 30 to 40% of the speed of light, very very fast. And in that area of the space, the things are so heated up that they are able to emit very high energy waves like gamma rays, etc., when they are getting heated up. So if the dark matter is there, when the energy transfer happens from black hole to dark matter, when they are only at last parsec, which is 3 light years away, then the dark matter must also get heated up. And then if it is heated up, then we should be able to see some evidence, but we do not see any evidence. So the scientists are saying that dark matter near the black hole must be interacting with each other and then taking the energy out. So dark matter may be responsible for the mergers, because we know that the mergers are happening. It's just that it's a mystery how they're happening. So our endeavor is to solve those mysteries, and this is one of the methods. Now, this method is only a hypothesis because we do not know what is dark matter. We do not know whether dark matter exists near the black hole. We do not see any evidence. We do not get any gravitational waves also. We don't get to see anything. So it is a hypothesis which solves this problem mathematically. But you know that, friends, that nothing is considered real until unless your mathematics is not backed by the real-time observation. So now scientists may be coming up with solutions if they can prove this theory. So this is the last parsec mystery. We do not know how the black holes merge, but this could be one of the methods by which scientists will be able to prove it. So thank you, friends, for joining me in this live stream. I will catch you again in the next one. Meanwhile, if you have any questions, any comments, feel free to send it. Bye for now.